So far in this section, we have talked about universal statements and existential statements. And in this case, on this definition, we'll describe a new kind of universal statement that we call a universal conditional statement. So this type of conditional statement is just like the previous ones that we learned. It has an if-then, but it also has a universal written in front. So the universal written in front describes the variable that the predicates are going to accept and the domain of that variable. So be careful and always write the domain at the start of the sentence. Just like before, these kinds of universal conditional statements have contrapositive, converse, and inverse. And as before, just like before, to get the converse, contrapositive, and inverse, you'll just have to negate some things and move some things around. Also keep in mind that the original and the contrapositive are still equivalent. The converse and the inverse are still equivalent, but none of these two on the left is equivalent to any of these two on the right. Let's practice this by looking at this example. If a real number is greater than 2, then its square is greater than 4. Let's see if we can get the contrapositive, converse, and inverse. Now keep in mind, in order to get all of these statements, you may have to rewrite the original statement that's written over here. And again, if you read it carefully, it says if a real number is greater than 2. So they're talking about a random real number, which means they're describing a universal type of situation. So beginning with that, we can rewrite the universal conditional as follows. For all x in the real numbers, if x is greater than 2, then x squared is greater than 4. And keep in mind that the contrapositive is just going to negate the p and q and it's going to swap them. It does not affect the domain. So when I rewrite the contrapositive, I must negate the original p and q that were there and rewrite their locations, swap them. So this gives me, for all x in the real numbers, if x squared is less than 4, then x is less than or equal to 2. The converse will just swap the original conditional p and q predicates, but it will not negate them. And then finally, the inverse will negate, but it will not swap the original predicates in the original conditional. So negating x greater than 2 and negating x squared greater than 4, we get the following.